Okay, what happens if the denominator is not a perfect square? You must rationalize it. Rationalizing the denominator is the process of eliminating the radical from the denominator. Now I know that's misspelled, y'all correct it. Denominator. Okay, so you have to watch this. The way you eliminate it is that you're going to take, just like you did in fractions, when you had to find common denominators, you multiply by the denominator. So we're going to multiply by the square root of 7, both the numerator and the denominator. So this leaves me with 5 square root 7 over the square root of 49. Well, what does that give me in the denominator now? Well, what's this called? A perfect square. So I'm left with 5 square root 7, because I can't do anything with the square root of 7, over 7. You're done. Okay? So let's look at the next one. So we're going to rationalize this again by multiplying 3b and the square root of 3b, and both the numerator and the denominator. Okay? What you have to do is we have to see 3 times 2 is 6b over 3 times 3 is 9b squared. Because you have b times b, which is b squared. All right? So, can I do anything with 6 if we're looking at perfect squares? 4, 9, 16, 25. No. No. Okay? So I'm left with square root of 6b on the top. And what is my denominator? 3b. Now, what I want you to do is I want you to take a second and look. What is happening to my denominator? From the original problem to the answer, what do you see in the denominator?
It's staying the same. It's just no square root.
Okay, it's staying the same without the square root. Why? Because if I take the square root of 7 times the square root of 7, I get 7. Because you're multiplying those numbers together. So you're actually, by rationalizing it and multiplying the numerator and the denominator by the same thing, you're just going to get that number without the radical. Okay? All right, I want to make sure you see that before we move on. Now, let's look at this next one. 3 over 2, square root of 2x. So we're going to say times the square root of 2x over the square root of 2x. All right? So we have 3 square root of 2x over 4x squared. Okay, can I do anything with 2? Square root of 2? Can I do anything with the square root of x? Just x? No. So I'm left with 3 square root of 2x over, what's the square root of 4? 2. And then what's the square root of x squared? X. Okay, this one, let's multiply by the square root of x, square root of x. So we get 1 square root of x over square root of x squared, which actually gives us what? Square root of x over x. Okay? All right, so now we have to separate this one out. Square root of 2x squared over the square root of 5. So now what do I do?
Multiply by the square root of 5.
So we're going to multiply by the square root of 5, square root 5. And we end up with 5 times 2 is 10 square root, 10x squared over the square root of 25. Because 5 times 5 is 25. All right? Now, square root of 10. Can I do anything with that? Can I divide 4, 9, 16, or 25 and do them evenly? Okay? What about this x squared? What can I do with it? It turns to an x and it comes and becomes the coefficient of our radical, right? So we have x square root 10 over what? 5. Okay? Let's try try the challenging one, and we'll write our summary, and we'll be done. Okay, so let's say square root of 8 over the square root of 3n cubed. Now we're going to multiply both the numerator and the denominator by the radical in the denominator. So focus on this part right here. What is 8 times 3?
24.
So the square root of 24